Let's prepare for the experience of studying Business Economics 2. This is Math 1324, and we're going to start with Chapter 2. Chapter 1 was a review of general mathematics. So we're going to start in Chapter 2, and it's all about matrix and linear systems. So, why are we learning it? Is it going to be used, is your question. And it is. We use it in production exclusively. I mean, it is used a lot. It determines your inventory with how much material is needed for each product the company produces. So that's that first picture. The second picture is one of an Excel sheet, which is nothing more than a matrix regarding type, quantity, usage, all of those considerations. So it is used there too. Farming uses a matrix or a linear system to figure out proportionally how much pasture land is needed for the farm animals, as well as how much land can be utilized for seasonal crops. So the last picture I show is one that is a definite matrix. It is the systematic change of several people in lines to create a shape or drawing in a marching band scenario. So all of these are items that use a matrix to make sure there is success in whatever they're attempting to complete. So now let's get started with our lesson. Our first lesson is Solutions of Linear Systems by Echelon Method. So to begin with, let's discuss what is a linear equation. Well, a linear equation is a degree 1 equation with one or more variables the structure. There's two. There's the standard form of linear equations, which is some coefficient on x plus coefficient on y equals some constant c. Now this is the one we'll be using. The other one that you're familiar with is y equals mx plus b. But in working with systems of equations, you can have more than two. You can have three. You can have a bunch. So that's why that system lends itself for production when you have many things that make one product. So that's why they're utilized. And they're not in the same fashion as y equals mx plus b, because a linear equation such as that one would measure how fast it's moving or not moving. So now we see the difference between the business aspect versus the algebraic aspect. So what is a linear system? It is a collection of linear equations where a common answer is needed. In other words, what is the optimization of it? How many can we produce of several things and still be having the whole plant working? Or how many changes must be made to create a design from a marching band? So it's a collection of linear equations at which are seeking a common answer. Well, that brings up the next question. What type of solutions are possible? Well, I got this from the textbook. But to understand, we can have one solution, which is termed as unique, no solution, which is termed as distant, nothing matches. And then we can have all solutions, which we call dependent. These three categories are specific for systems of equations because in each case, if we get a unique solution, we might have one variable, two variables, three variables, but it's only one unique that fits all of the linear equations listed. Okay, so there's a difference in that, so that all solutions, when they're called dependent, rely on one reference to determine the rest of the solution. So we're learning a lot now. We're learning how many solutions, and that we can have none, and that happens sometimes. All right, so how does it look graphically? Now, even though we're going to have more than just two, the book showed the way to visually determine the unique solution. Lines cross at one point. No solution, which was inconsistent. Dependent, which means they're both the same line. Sometimes in life, a picture is more impressive to the brain and recall. And that's what you need, is that recall capability. So let's see about using the echelon method to find the solution of linear equations. Now, we're not going matrices right yet, but we are going to do a physical approach to solving. And what I mean by that is that we're going to be using first finding one variable listed to cancel out by combining, that means to add, combining systems. And of course, this is for two, and that's what we're starting with. So we're going to try that. And the way we do it is find an LCM and ensure variables zeroed out are opposite sign. Well, once we do this and then we add them, we should have only one variable left. So once we have that one variable, we'll solve for that value. Well, once we do that, we're almost home free, because our last fourth step is to substitute into one of the linear equations to find the missing value. And then we will test it, of course. Again, you'll be using your calculator, or you do it on paper. It doesn't matter which way you go, but you always must check your solution. And I'll be following through on this as we go through. Okay, so now we're ready for first to check for understanding that you've understood what I've just stated, at least with one of the questions, and it's a main one. It says, true or false? A system of three linear equations in three unknowns can have exactly three solutions. No, false. Can have one or none or all, but not three specifically. And they're talking the variables. Well, if we're talking the variables have only one solution for the comparison of the other two. Every one is interrelated. As we solve them, because I will be checking either by calculator or by actual expansion. So let's do an example and see what we can finally get to in this lesson. Here we go. So we have a linear system, 3x plus y equals 11, 4x minus y equals 10. Now this is an example where the variables, one variable zeroes out. So we don't have to do any math to the system. We just have to add vertically. So our first step is to add vertically. And zero out the variable y. All right, let's do it. So I have a 3x plus the y equals 11. I have a 4x minus y equals 10. So I'm going to add vertically. 3x and 4x is 7x, but at y minus y is 0, and then we're going to have 21. Well, now we're going to solve this equation. I'm going to divide both sides by 7, so x is 3. We have 1/2 of the solution. All right. So now remember, we're going to what? substitute the solved variable x equals 3, if my math holds out, right, to find y. So here we go. And it doesn't matter which equation we use. So if I use 3x plus y equals 11, and I insert 3 for x, and I'm going to have, oops, you see it, I know you do, 9 plus y equals 11. We could guess the answer at this point, but we're going to subtract 9 so that y is 2. So now we're stating, and an answer is always xy, so it's going to be a 3 and 2 is a solution. But we have to, before we stake our life on it, we're going to check it. Now, if your math is incorrect, it'll show up on a check of both. So I'm going to have 3 times 3 plus 2 is 11. And we know that one's true. So the next one is the one we're going to do. 4x minus y equals 10. 4 times the 3 minus the 2 equals 10. 12 minus 2 equals 10. So 3, 2 is a unique solution to the system. Nothing hard. Now remember, I'm in instructional mode, but you need to be categorically thorough, and so that's what I'm being for you. So we have another example, and we notice negative 3y and a 9y, but we need this to be a 9 to zero out. So our first step is to multiply line 1 by 3. Then add vertically. All right, so here I go. I'm going to have 3 parentheses 12x minus 3y equals 6. And I'm not going to change this one to x plus 9y equals 20. So I'm going to move them over, and that's going to be 36x minus 9y equals 18. Now remember, you do it to every term of the equation, even the solution. Otherwise, you'll get a wrong answer. And now I bring forward the no change one, and I'm going to add vertically. So this is going to give me a 38x. This zeroes out, and then I get equals 38. Well, then we know x must be 1. So we have one part of our solution. So we're going to get the other part. We're going to do by substitution. To find our y value. So here we go. And it doesn't matter which equation, I'm going to use the second one. 2x plus 9y equals 20. 2 times 1 plus 9y equal 20. So then I have 2 plus 9y equal 20. I'm going to subtract the 2. That leaves me 9y equals 18. If I divide by 2, I'm sorry, divide by 9, I gave you the answer. Sorry, y is 2. So we have a solution for this one. All right, so now we're going to find the value of y. Check it, sorry. Because we know our ordered pair is 1 and 2. So now we're going to check it. Sorry. So I'm going to use it to both of them, right? 12x minus 3y equals 6. And 2x plus 9y equals 20. 12 times 1 minus 3 times 2 equals 6. 12 minus 6 is 6. Now that's true. 2 times 1 plus 9 times, what do we say over here? 2. Sorry about that. Equals 20. 2 plus 18 equals 20. So that checks. Therefore, 1, 2 is a unique solution to the system of equation. All right, so I'm going to stop right here, and then we'll take up more examples and get a little more involved. Now, we've only done some that have had unique solutions, and we'll see later some that are not unique solutions. So thank you for listening.